Hello, my name is Isaac, and for this video, we will go over a geometry problem which I will dub the Hachama Heart Breaker, because this problem was rather difficult. One of the main reasons this problem was so difficult is because the statement of the problem is quite unclear at first. So let's give it a careful read. So let's go ahead and start. Hachima draws a heart on a piece of paper, which geometrically is a square with side length 10, with two semicircles externally attached to two adjacent sides, which are the diameters. So what that means is that you draw a square, and then you draw two semicircles outside of the square whose diameters are on those sides. After labeling the centers of the semicircles P and Q, Hachima then plots a point R inside the square and draws the rays RP and RQ, which divides the heart into two regions. We are given the following lengths, PR equals 1 and QR equals 7, and we are asked for the positive difference between the areas of the two regions. So let me go ahead and reveal the diagram. The diagram is this before we draw the circles. So firstly, before we draw the circles, since the centers of the semicircles divide the diameter into two equal parts, the diameters are the side lengths. So P is the midpoint of its side and Q is the midpoint of its side. And the square has side length 10, so these lengths here are 5. Okay, now we can draw the semicircles outside. So here's our semicircle like this. Let me draw it again. Here's one semicircle, here's the other semicircle, and you can see why this is called a heart, because if you rotate it 45 degrees, it looks like a heart. Okay, finally, we want to plot the point R. So we'll put R here so that it looks like this segment is short like this with length 1, and this has length 7. And we extend the rays RP and RQ, and this splits the heart into two regions. Here's one of them, like here, and the other one is the region outside, or to the right. So how do we find the positive difference between the areas of these two regions? Well, the circles are definitely the hardest to tackle here. So if you see this diagram like this, we first don't really know anything about what the areas of these circle portions are, so we'll try to find information about some other aspects of the diagram. So what can help us here? Well, we know the length of PR and we know the length of QR, and if we can find the length of PQ, that'll tell us some information about the triangle PQR. Well, it turns out that since this is a right angle here, we can find that the length of PQ by the Pythagorean theorem, or 45, 45, 90 triangle, is 5 root 2. Okay, but by Pythagorean theorem again, we can notice that 1 squared plus 7 squared equals 50, but this is also equal to 5 root 2 squared. So Pythagorean theorem actually tells us that this is a right angle, and this helps us greatly. Now, since this is a right angle, we can note that if we rotate this sector 90 degrees about the center of the square, this rotates all the way to here. So these two regions are equal, and we can do the same thing with the with this region here. If we rotate this region 90 degrees about the square, we can see that it lands here. So these two regions are equal. But hey, this means that the area of these two regions is equal to the area of these two regions, like here. So actually, all we need to worry about now is the area, the areas in the square. So let's calculate the area of this region here, which consists of P, R, Q, and this, this square vertex. So the area of this region here inside the square is equal to the area of this triangle, which is 1/2 times 5 times 5, plus the area of this triangle here. We take the legs 1 and 7, so 1/2 times 1 times 7, and this comes out to 16. And now let's find the area of this region here. The area of the region inside the square but outside this region here is equal to the area of the whole square, which is 100, minus the area of the blue region here, 16, and this is 84. Finally, to find the positive difference between the areas, we subtract 84 and 16, and this gives us a final answer of 68.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.